Okay, before we get into the meat of really working percent problems, I want to spend a little time wrapping together the whole concept of fractions, decimals, and percents. Basically, what I want you to pull out of this is that fractions, decimals, and percents all allow us to communicate and calculate about portions or portions of a whole. So it makes sense that you should be able to convert back and forth between fractions, decimals, and percents. And so this video is really going to focus on that aspect of things. Okay, so what I'm going to do is I'm going to start out with three very basic fractions here, and we're going to convert them to both decimals and percents. And I know that we've done some of this when we were talking about fractions and decimals, but now we're wrapping the percent component into this. So I think all of us remember back when we were converting from fractions to decimals, you needed to interpret a fraction as a division problem, the top number divided by the bottom number. So we're going to go ahead and we're going to do that here. So we're going to say 4 goes into 3, or 3 divided by 4 by putting the top number inside the house, the bottom number outside. But the deal is, what's unique here is that 4 doesn't go into 3, not even one time. So what we're going to have to do is we're going to have to place a decimal and zeros so that we can continue working out our problem. So I write a decimal here, bring the decimal up in my answer, add a 0, so now I can ignore all my decimals and just start dividing. 4 goes into 30 7 times, so 7 times 4 is 28. And when I subtract, I find that I have 2 left over. I can add another 0. As long as I have a remainder here, I can keep adding zeros, bring it down to complete this. 4 goes into 25 times. Okay, so we may have done this before, maybe not. But the deal is that you recognize that because this is a fraction less than 1, it makes sense that my answer is going to be a decimal less than 1. So now the deal is we need to convert this to a percent. Percent means, basically you need to remember that percent means per 100. So you can kind of keep that in mind. So basically 75 hundredths is already in that mindset or that format of out of 100. So we can convert this, we can take this decimal, move it 2 places to the right, and write that as 75%. So we have this 75% here, 75 hundredths, and 3/4. All three of these are communicating the same portion. Okay, so now we're going to try another fraction here. We're going to say 5/8. So the 5 goes inside the house, the 8 comes outside. 8 does not go into 5, not even one time, so I have to place a decimal in my answer, add my 0, and now I get cooking with my division problem. 8 goes into 50. 6 times 8 is 48. When I subtract, I find that I have 2 left over. As long as I have a remainder here, I can keep adding zeros, bringing my 0 down. 8 goes into 20 2 times. So 2 times 8 would be 16. And I find that in this case I have 4 left over, so I'm going to have to add another 0. Bring that out. Bring my 0 down. 8 goes into 45 times. So you can see here 5 times 8 is 40. I wouldn't have to subtract this and complete this. But you can see that it's really important that you line up your place values, or you could get your answer all goofed up and be going farther than you really need to. So kind of get in that habit of keeping your work aligned. Okay, so what we know here is that 625 thousandths is equivalent to 5/8. Now again, from what I told you over here, going from decimal to percent, you just move the decimal 2 places to the right. So I move this 2 places to the right to get 62.5%. And basically what you're doing is you're taking that decimal and you're multiplying by 100. Some of you may have learned that is take your decimal and then multiply by 100 to get the percent. But when you do that, just make sure that you insert the percent sign, because now it's in percent format. So now in this case we have this portion written as a percent, as a decimal, and as a fraction. So we've got three different problems going on here. Okay, so you can see here that this one ended after 2 decimal places. This decimal ended after 3 decimal places. In this case, we're going to take 2 divided by 3, so 2 goes inside the house, 3 comes outside. 3 doesn't go into 2, so we're going to have to place our decimal, place our zeros. 3 goes into 20 6 times. 6 times 3 is 18. So I find that I have 2 left over. I can add another 0 and bring it down. And I recognize that, wow, 3 goes into 20, still 6 times. So this is going to keep happening over and over and over again. We're going to find that this is one of those that's going to go on and on forever. So at this point I can stop and I can just put a little bar up there just to say that this is repeating. And in this case, because it's repeating, I'm going to have to decide where I want to round this off. And usually we round it to the second place value, knowing that 3 goes into, I wrote a 2 here and I did not mean to do that. 3 goes into 26 times. I can usually round this off here at 1 place value. 2 place values be the hundredths. Going to the right, that's greater than 5, coming back to make that 0.67 is very often how we want to round that. And then you can convert that, moving that decimal 2 places to the right, would be 67%. So either of these, the decimal, either of those, or you could have gone farther, would work. And then we have this fraction. So all of these are congruent to each other. And again, we probably know that one. Just know that when you have this going on and on forever, you need to make a decision where you're going to round it. Usually going forward in our next chapter, our next units, I will give you specific rules on that as to where and how to know where to round. Otherwise, you need to really keep going until it does complete. And for the most part, you're probably going to be using a calculator, and I know that. I just really want to make sure that you understand the significance of how these fractions, decimals, and percents all communicate the same portion. Okay, so here we've got a case where we've got our percents and we want to convert them to, say, decimals or fractions. If I have it in percent form, notice up here when we were going from decimals to percents, we moved 2 places to the right. So it kind of makes sense that when we have percents and we're moving to decimals, we're going to take our implied decimal here and move 2 places to the left. So you could look at that as 68 hundredths. Now if I really needed to, I could convert that, I could write that as a fraction, 68 hundredths. Notice you're saying these exactly the same way. 68 hundredths in decimal form is spoken the same way as 68 hundredths in fraction form. But in fraction form, I can divide both numerator and denominator by a common number, and I know that 4 goes into each of these, and that would give me 17 over 25. So that would be the case if you needed to convert back from, a fraction, from the percent to a fraction, or from the percent to a decimal. So all of these 3 are communicating the same thing. For the rest of these, I'm just going to focus on converting from percent to decimal. So in this case, I have a percent and I need to move to a decimal. And I've got a decimal right here, so that means I'm going to have to move it back 2 places. But that means I'm going to have to insert a 0 as a placeholder. So 35 thousandths is equivalent to 3.5%. Okay? I'm going to draw my lines here. In this case, I've got 125%. I've got an implied decimal here, and I could move 2 places back, and that would give me 1.25 when I write this in decimal form. So here's our decimal in each of these cases. A lot of times students get confused, especially when you have odd things like this. A really small number that already has a decimal in it, you had to move and you had to insert a 0 as a placeholder. Students can get confused with that. Sometimes percents greater than 100, students also get kind of confused with that. How come we have a 1.25? In business, percentages greater than 100 happen quite often, and in science, percentages less than, or decimals that go to 3 place values happen quite often as well. So we're going to have some practice to make sure we're comfortable with that. But in a nutshell, knowing which way to move your decimal. This is just something that I've shared with students, and they've told me that they, rely on it all the time. You know that it's all in what you're moving to. You know that there's going to be a play on words, that you're moving to a percent. You know that you're going to have to move 2 places. Everybody's got that down. But when you're moving to a percent, you know that you're going 2 places to the right because there's an R in percent. That isn't actually a Y, but it's a little way that you can use to keep yourself straight. On the other token, if you're moving to a decimal, again, you know that you're going to have to move 2 places, but you're going to move 2 places to the left because there's an L in decimal. Again, that's not really Y, but it'll help us remember. Okay, one thing that I do want you to know is as you are calculating with a percent, this is huge. In order to calculate with a percent, you must convert it to either a fraction or a decimal form first. So we're going to spend a lot of time practicing and making sure that we can accurately convert back to a percent or a fraction depending upon, or decimal or fraction depending upon what we need. So whenever you're asked to find a percent, you might do some calculating, and then you'll have to move your outcome, your answer, from a decimal form to a percent form. So you really have to understand this moving and converting back and forth between all versions.